What we're going to do in this video is graph the parent function for the absolute value. So f of x equals the absolute value of x. So we want to find some ordered pairs. So we're going to evaluate this function. So remember the x is going to be your domain, what you're going to substitute in, and the y represents your range of what you're going to get out. And we're always substituting into right there. So let's just try a few numbers in the negative direction. So -3, -2, -1. And then I'll try a few numbers in the positive direction. So we have 0, 1, 2, and 3. So you want to say f of -3, what would be its value? So you're substituting it right here. So the absolute value of -3, remember when you take the absolute value of anything, you're going to get a positive number out. The absolute value of -2, you're going to get a positive number out. Absolute value of -1, get that positive number out. Absolute value of 0 is still just 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Absolute value of 3 is 3. So now let's take the time and graph these on a coordinate plane. So -3, 3. Just create, I'm going to make this coordinate plane a little bit wider just so it's easier to see. So here is 1, 2, 3, -1, -2, -3. All right. So our first order pair, -3, 3. So we're going to go left 3 and up 3. Then our second order pair is -2, 2. So we're going to go left 2 and up 2. Our third order pair is left 1, up 1. Our fourth one is 0, 0. And then we go right 1, up 1, right 2, up 2, right 3, up 3. And notice what appears is the shape of a V when we connect the points. So the shape of an absolute value will always look like a V. And that's how we graph the parent function for an absolute value. Now the next slide is a little overwhelming. These transformations will become very important for you as we move through the class. Our first transformation that we're going to talk about from its parent function is a vertical shift, moving the entire graph up or down. And where this happens is it's going to be either a plus k or a minus k. If it's a plus k, it's going to move up that many units. If it's a minus k, it's going to move down that many units. The next piece in the purple is a horizontal shift, picking up the entire graph and moving it to the left or to the right. So we have to think opposite, and it's going to be inside the function. So notice if this is a minus h, we're going to be shifting to the right. If it's a plus h, we're going to be shifting to the left that many units. Then the next transformation that could occur would be your reflections. Reflections across the y or the x-axis. If it is inside the function, then we're going to reflect it about the y-axis. If it's in front of the function, then we're going to reflect it about the x-axis. The next one in the green is your vertical stretches or compressions. If your number is in front of the function and it is greater than 1, you're going to have a stretch away from the x-axis. If you have a number in front of the function, a multiplier, and it is a fraction or decimal place, you're going to have a compression towards the x-axis. The last one here in the blue is your horizontal stretches or compressions. What you have to do is you have to reciprocate the b, and it always will be inside the function. So inside the function, 1 over b, and if b is greater than 1, that's going to stretch away. If it's 1 over b, and your b is a fraction, then it's going to compress toward the y-axis.